in this video, we'll be talking about a multiple choice question regarding towards how to calculate hydroxide ion concentration. Actually, this question, each choice actually going from sort of a different angle how to calculate or figuring out how to calculate hydroxide and practice many basic skills. So it's a good question. Now let's look into it. Okay, so the question is asking us which one has the lowest hydroxide ion concentration. So apparently, in order to figure out which one is the choice, we need to calculate the hydroxide ion concentration for each choice. Okay, so then let's start from choice A. Okay, so choice A is saying we have a solution with a pH of 3.0. Okay, so then therefore we could calculate, right? We could calculate hydronium ion concentration from the given pH value, then use the relationship between hydronium and hydroxide ion concentration, then we can calculate hydroxide ion concentration. Okay, so then we will go from the angle, or you can actually go, maybe we'll go the other one, so then we can do a quick practice. Okay, so again, we want to get to hydroxide ion concentration. In order to figure this out, we can actually go to pOH, right? Okay, so with given pH, we can get a job done. Okay, so let's do that. Okay, so in order to calculate pOH, we could use the relationship. Of course, all the information given is talking about at 25 degrees C. So 14 minus pH, that will be 14 minus 3. So that's 11. So pOH is 11. So from here, we can use the relationship and then knowing how to calculate pOH. The hydroxide ion concentration, that will be 10 to the power of negative. pOH will be 10 to the power negative 11. Okay, so then you will be able to get to the concentration, right? Numerically, very easy. So hydroxide ion concentration, if you want, you can use 1 times 10 to the power of negative 11. Okay, so then it's concentration. Okay, so then we got one done. Okay, so then let's see next. Okay, so for the next choice, I'm going to do it right over here. Okay, so choice B, 1 times 10 to negative 4 molar solution of nitric acid. So we have to know what it is. Okay, so nitric acid is what? Is a strong acid. Okay, and since it's a mono, so what does that mean? Everyone out of this nitric acid will be 100% dissociating to hydronium ion and nitrate ion. So then therefore the concentration of this nitric acid will equals to 1-to-1 ratio hydronium ion concentration, therefore equals 1 times 10 to the power of negative 4. Okay, so then it's concentration, but what are we concerned? We want to know hydroxide. Okay, so then therefore we can use the relationship. So now we go the other way. Okay, so we can use, right, since hydronium times hydroxide equals to Kw, so Kw divided by hydronium ion concentration will equal to hydroxide. Okay, so at 25 degrees C, Kw equals to 1 times 10 to the power negative 14 divided by 1 times 10 to the power negative 4, which will give us 1 times 10 to the negative 10 molar. Okay, so then that's in the second solution, the hydroxide ion concentration. Okay, so now let's look at the next one. Okay, so next one, we will work on it over here. Okay, so let's see. Okay, what kind of solution we have? We have, right, directly telling us we have a pOH of 12. Okay, so then we can simply use that relationship. Okay, so the hydroxide ion concentration, when we know pOH, we just use 10 to the power of negative pOH. Okay, so it's 10 to the power negative 12. Okay, as we know, this will be, if you want to express it this way, it's 1 times 10 to the power negative 12 molar. Okay, so then that's the concentration for choice C. Okay, so then let's see choice D. Choice D, we have pure water. Okay, so at 25 degrees C, pure water. What does that mean, pure? You have no other ions to interfere with the concentration. So in pure water, hydronium ion concentration equals to hydroxide ion concentration. Okay, and then they also have the relationship Kw equals to hydronium times hydroxide ion concentration, since they equal to each other for pure water. So we can swap, right? Swap that. So then we have hydroxide ion concentration times hydroxide ion concentration squared. Okay, so then since Kw at 25 degrees C equals 1 times 10 to the power negative 14, so we'll be able to calculate what's the hydroxide ion concentration by doing square root of Kw. So that will be giving us 1 times 10 to the power negative 7. Okay, so then that's the concentration for hydroxide ion in pure water. Okay, so then that's 4. Okay, so again, by so far you go, oh, C has apparently C was the answer. Okay, but then let's look into E. Okay, so let's look into E. I'm gonna copy that so I have some more space. Okay, so E is a slightly more complicated than the other situations. So then let's look into it. Okay, so E, then we'll have to think about what we have for E as a solution. Okay, so then let's see what's this. Okay, what is it? Right, that's ammonium chloride. You go, oh, that's a salt. Right, how does soluble salt behave? It's going to be 100% dissociating 2 ions. So in this solution, you have ammonium ion and chloride ion. Which one will be affecting hydroxide or hydronium ion concentration? The species are could affect it, right? So which one will not affect it is that chloride ion, which is pH neutral. Okay, so then we don't need to concern about that. So then we just need to study or talk about how ammonium ion is going to affect or behave in the aqueous solution. Okay, so ammonium ion itself is what? Is the conjugate acid of a weak base. What weak base? Is ammonia, right? Okay, so then let's see, as a conjugate acid, as an acid, how is it behaving in aqueous solution? Donating a proton, end up with ammonia, and well, since it's acid, donating proton, right? Water behaving as a base, so accepting proton, so producing hydronium ion for us. Okay, so then again, since it's acid, so that's gonna be Ka. Okay, so then hydronium ion concentration. If I can figure out hydronium ion concentration, I can figure out hydroxide from there. So then let's set up as table solving this. Okay, so then what's the ammonium ion concentration? It's given right over here, so it's gonna be 1 times 10 to the power negative 3. This is, we don't concern about that. Here it's gonna be 0, approximately 0 in the beginning. Again, this is negative x, positive x, positive x. 1 times 10 to the power negative 3 minus x and x and x. Okay, so Ka equals to x times x divided by 1 times 10 to the power negative 3 minus x equals to, you go, oh, this doesn't give me a value. If this is an actual assessment question, so then we have to provide a value for you. Okay, so then probably we'll give you, just say if we give you Kb value for ammonia, are we able to calculate the Ka value for ammonium ion? I believe so, right? Using Kw divided by Kb. Okay, so the Kb value for ammonia is 5.56 times 10 to the power, I'm sorry, it's actually, I'll give you the answer. Okay, so the Kb value for ammonia is 1.8 times 10 to the power negative 4, and therefore the Ka value for ammonium ion is 5.56 times 10 to the power negative 10. Okay, so then this is a value we can use. This is a K, so then small enough, small approximation, cross multiply, so we can solve this x. Okay, so therefore this x solved as 7.45 times 10 to the power negative 7. Okay, and this value equals to what? Hydronium ion concentration. What's our concern? Hydroxide. So how do we calculate this? Kw divided by hydronium ion concentration. Finish this, we'll get about 1.34 times 10 to the power negative 8. Okay, so then this is the concentration of hydroxide in that salt solution. Okay, so now we solve for each choice. Now we can finish off our comparison. Okay, so then which one is the lowest concentration, right? It's quite obvious. So then that's also why the answer was C. Okay, so then hopefully this is helpful. A question, practicing basic skills, and then definitely we should know the skills. Okay, thank you for listening. Hopefully this is helpful.